Alright, good afternoon. My name is Andrew, and we're going to be talking about select data structures. As Oscar said, Charlie's going to give us curriculum, so for today I just chose one topic that I think best showcases my teaching style. Okay, and that topic is lists. This is a list. This is also a list. This is a list of lists, and this is a list of lists of lists. I'm sure you guys have seen these before. A list is just an enumeration of items. It's just items after each other. And today we're going to learn how to do that in Python. I could just show you guys a PowerPoint, but I think PowerPoints are boring. So instead, I just pulled up an IDE and we're just going to go through this together. Okay, let's start by giving some examples of lists. So for example, someone give me some colors. Oscar.
Blue.
Cool. Okay, so let's have a list of colors. Let's start with blue. I like the color green, so I'm going to add green to that. Red, orange. Let's add yellow to that for good measure. So as you can see, I'm creating a list right there. And also, is the text big enough for you guys?
Yes.
Okay, this is like 2 times the normal text size, so hopefully it's enough. Yes, and as you can see with the syntax, you start a list with this square bracket. It's right next to so like you can type a P and it's right next to the P key. You don't want to use like any other brackets. Python specifically wants a square bracket. So, for example, I could create another quote-unquote list and do this. This is not a list. This is something else. Don't do this. Also, don't do this, because this is also not a list. If you want to create a list, use square brackets like this. For more examples, I'm going to give some more. So for example, prime numbers, they are 2, 3, 5, 7, 11. Those are the first 5. Members of our family. This could be mom, dad, me, and say brother. And and say my grades in school. This is what I hope they're gonna be. They might not be 100% accurate. This is gonna be my grades next year, guys. I'm gonna have AP US History, and I'm gonna get 100%, 100%, 100%, and 100%. Oscar, is that right?
No.
Aww. We're gonna pray that Oliver doesn't come me. Okay, so you might be noticing something about these lists. Specifically, well, other than the fact that they start and end with these brackets, they also have commas in between. And that's important, because I'm gonna break this list. Let's say I'm gonna create another family array. But we're not going to add commas. It's going to be like this. And as we're going to see, let's see what happens when you run this. Oh shoot, I closed it. Hold on, technical difficulties. Let's add a number for good measure. And let's see what happens when you run this. So what we see is that Python gives us an error. Does it give me an error? I hope it does. Hold on, guys.
I don't think you have the console open.
In theory, oh, there we go. So what we notice is that Python tells us invalid syntax. Okay, how do we fix this? I just showed you guys. You add a comma, you add a comma, you add a comma. Do we add a comma here, guys? You're correct, we add a comma. And now if you run this, nothing happens, because it's correct code. Thank goodness, I'm a good coder. I know how to fix bugs. Whew. Okay, that's part 1. How do you define a list? Now let's talk about how to actually use a list. Because like, we can have this, but like, how do we actually use this in a program? In order to print a list, you just run the print function. You write print, and then 2 round brackets. Don't use the square brackets this time, the round brackets. They're above 9 and 0 on your keyboard. And just print any array that you want. List, that you want. For example, family. Oh, nice, there we go. Let's use another one, primes. If we just run print primes, it gives us the list of primes. If we run print colors, it gives us blue, green, red, orange, and yellow in sequential order, like that. But like, we don't always want to use a list. Sorry, we don't always want to use the full list. For example, what's the point of using a list when you can only see the whole thing? And that's when we talk about indexing. Each of these numbers in a list, they're given a number. It's called an index. And in order to retrieve a number with an index, we just do something like family, comma, the number. So let's see what this happens. Family 1, we expect to give the first number, right? But it gives the second number. Wait, I'm gonna run that again to show you guys. Family bracket 1. This gives the second number. That's weird. Advash, right? Ashvash. What do you think will happen when we run family 2?
I think it will give the third number.
Cool, okay, what about 4? Ashvash. Yes, you're correct. Every time we increment this, it gives the next number. Okay.
I have a question.
Yeah, Oscar.
But did you mean to create 2 families? Because are you gonna explain like what happens if you create 2 lists with the same thing?
That's a good question. I did not mean to do that, but we can talk about it right now. That's an awesome question, by the way. Thankfully, lists are mutable. That's what it's called in Python. That means that once we create family, like the first family variable, right? If we try to make family something else, for example, by adding a 3 at the end, Python won't yell at us and tell us we're doing something wrong. Because the way Python works, family is a variable, right? You can redefine variables. So family used to be this list, now it's this list. Does that answer your question?
Yeah.
Awesome, cool. Okay, Michael, what happens when we do family 5? Notice that there's only 5 elements in this array.
It gives an index out of bounds.
Oh yes, you're correct. Because as we've seen so far, this is index 1, this is 2, this is 3, this is 4. So when we call 5, Python's like, bro, 5 doesn't exist. What are you doing, dude? Cool. That's correct. When you try and access an index that's not in the array, Python yells at you saying you're doing something wrong. But we haven't found a way to get mom yet. And as it turns out, that's 0. Because the way Python works, and pretty much any programming language, you count starting from 0. So this is 0, 1, 2, 3, 4. Does that make sense to everyone? Awesome, okay. And what's your name in the back? Rithit. Ah, that's right. What do we think will happen when we decide to go into the negative numbers? And we call family -1.
I have no idea.
Take a guess. Take a guess. Do you think it will error? Do you think it will give the last number? What will happen?
I think it will give the last number.
Yes, you're correct. When we call family -1, it gives 3, which is the last number.
Yeah.
Most programming languages won't do this. They hate when you do this. But Python
is nice.
Yes, it is so nice. We can keep going too. -2 gives the second to last number, -3 the third to last, fourth to last.
Does it mod it?
Fifth to last.
Does it mod it? If you do -6, will it go back to 3?
I don't know. Let's try it. In fact, it doesn't. Yeah, I hate Python. No, it's actually really nice. Okay, does indexing make sense to everyone? Just to recap, it goes 1, 2, 3, 4, 5, -1, -2, -3, -4, -5, and error, error. Make sense? Cool, okay. But, look, here's the thing. A list is useless unless you can add things to it or remove things from it. So that's what we're gonna cover next. Say we're making a cake, right? I didn't bake, so I had to ask my mom and Google for this. If we want to make it a list of ingredients for the cake, and we just want to add things, we just call the function append. This is the syntax, by the way. For example, we can append eggs. Hopefully you guys see the pattern. We can append batter. If we just print the cake right now, we'll see that eggs and batter, they magically got added to the end. That's cool. Okay. Say we're making a chocolate cake. We can add chocolate. Do I know how to spell? I do know how to spell. If we add chocolate to the end, we get chocolate appended to the list. which is very nice. But say we don't want chocolate in our cake, right? And we want to remove it. Then, oh, is the screen like angled this way? I can like move it this way if you guys want.
It's good.
You guys good? Okay. And if we want to make, say, a vanilla cake instead, we can just remove chocolate. Like, you'll find that Python is very self-explanatory. The remove function removes things. The append function adds things. If you want to remember, like, the word add starts with the same letter, A, as append. Okay, so we want to remove chocolate and we want to add vanilla. And we'll find that that's just what happened. Awesome. Okay. Cool. And that's pretty much it for modifying the array. Finally, let's talk about some functions that you can use to better handle lists. For example, say we have a list of lucky numbers, right? Lucky equals 1, 2, 3, 4, 5. And we want to see if, Michael, what's your favorite number?
0.
0? Okay. So we want to see if 0 is lucky or not. So what we can write is, if 0 is in lucky, you see it's very self-explanatory. Indent, print, 0 is lucky. Ideally, students would have learned control flow by now, since I teach the 3rd week. And else, we print 0 is not lucky. So, Michael, what do you think this will print?
0 is not lucky.
Wait, I screwed up somewhere. Oh, shoot. It's just 0 in. Sorry. Man, I'm bad at this. Yes, 0 is not lucky, because as we see, 0 is not in 1, 2, 3, 4, 5. And if we want to loop through the array, right? If we don't like these brackets, what we can do is we can loop through the array like this for a number in lucky. What this will do, and then we can print number. And as we can see, this will print out 1, 2, 3, 4, 5. So how this works is that Python goes through each number in lucky and assigns it to number. So first it goes number equals 1, and what do we do with number equals 1? We print number, we print 1. Number equals 2, print 2. Number equals 3, print 3. Number equals 4, print 4. Number equals 5, print 5. Does that make sense? Excellent. Okay. Oh, yeah. Something else you can do with lists is that if you just want to modify a single element, so for example, we don't want the first element to be 1, we want it to be like 16, which is my lucky number. The index of 1 here is, the index of 1 here is 0, right? Lucky brackets 0 equals 1. So we can just change it like this. If we print lucky again, we see that the index at 0, which is again the first number, because Python indexing starts at 0, then goes on sequentially. It turned into 16. Okay, before we go on to the practice problems, does everyone understand what everything I just said? Like, kind of makes sense? Yeah. Cool, okay. Let's talk about the practice problem then. Okay. So the practice problem we're going to do today is we're going to ask the user for 5 names like this. We are going to put the names in a list. We're going to sort the list. I'll teach you how to do that in a second. And then we're going to query the 3rd name. Ideally, students would have computers out right now. I would ask them to converse with each other, try and solve this together. But let's just assume that we got a time machine, 15 minutes have passed, and they've come to a solution. I'd ask students to show their solution on the board, but if no one shows it, I'm just gonna code it on the spot. Okay, let's just pretend that I just code this on the spot. we jump forward like 5 minutes in time again. So we would ask the user to enter 5 names. We create a list, and then for I in range 5, recall that all that does is loop through the body of this for loop 5 times. So we ask the user for a name through input function, then we append it to the list, and at the end we dot sort it. And then recall that Python indexing starts at 0, so the third name is actually the second one. Sorry, it's index number 2. So we just print it out like this, and we can verify it works by inputting 5 names, and this should give C, which is correct. Okay, before we end, I'd just like to quickly summarize everything we've learned in a table like this. Just recall that, again, Python indexing starts at 0, then goes 1, 2, 3, 4, 5. If we want to find something that's at the index, we just put it in square brackets and write it after the listing. .append adds it to the list. There's some functions that I guess we didn't talk about today, but length of the list that gives length of the list. List.pop index that gives, instead of just finding whatever is at that index, you just delete whatever's at the index. If you do something like for if item in list, that checks if an item is in that list. This is slicing. We didn't talk about that. And we talked about this for item in list that loops through the list, and you can use this index to modify the list. Okay, are there any final questions? All right, then. Thank you, everyone.
So yeah, still me. Yeah. First, great interaction. You do the wrong example to confirm the right example, so that's great. And you involved almost every student in our class discussion. That's great. And you are the only one do review part for kids. That's great. Thank you. And another thing, I think you need to consider how to move forward if your student can't answer your question. You know, yeah. Perhaps you need more steps, more details for that. Yeah. And I'm not sure. Do you need some paper materials for kids?
I do think that it would be helpful to like print the reference out.
Oh, that's okay. Okay, and I think perhaps you can build a single story about your coding class, like your family baking, like that.
Oh yeah.
Perhaps that will be interesting. Yeah. Thank you. Yeah. So great. Thank you.
Thank you. Yeah. Oscar.
I know you said like have like the students explain their solutions if they finish one. So I was thinking like that we have like rooms with whiteboards, right?
Small whiteboard, but yes.
So like I think the whiteboard will also be useful if you can't print out a reference sheet, because you can write down like I know for the indexes you can write down a list and then just write 0, 1, 2, 3, 4, so they don't forget how indexes is like the 0th for the first one. And then the whiteboard can also be useful if they want to come to a whiteboard and explain the solution. So it's like a.
If your kids need the large size whiteboard, you can tell me. I have 2 large size. I'm not sure about. Yeah.
Oh yeah.
Yeah. If you need.
Yeah.
If you need.
Do you guys have feedback?
No, I think it was really good. I think, are you planning to have more than just like one practice problem? Because obviously this was
Definitely. Yeah.
Yeah. Okay, that's the only thing I was. Yeah.
I mean, the only thing I'd say is that for like a longer lesson, I think you'd probably want something to do that. I know that they're gonna be pretty focused on like the coding stuff, but you probably would want something for them to just like get up and take a break, because I think otherwise it would become somewhat like monotone and very, you know.
Boring. Yeah.
Yeah. I mean, I don't think it's boring. I think you have like a good